Hi, and welcome to question 3 of paper 2 2020 ordinary level leaving cert maths. So if you want to copy the notes I'm working off, just send me an email at shanetry@gmail.com. And if you click subscribe, you'll get access to more playlists. So this question here that we're looking at is on probability. Okay, so the pen will start working. It is working now, sorry, sometimes it doesn't work. So the first question here says, in a survey, 1,000 people are selected at random and asked some questions about online shopping. Part 1 says, find the margin of error of the survey. Give your answer as percentage, correct to one decimal place. So look, if you can't do the first bit, the second bit doesn't matter. This is the most important thing. Now, the margin of error in formula, and I always struggle to find this, okay, but I'm not sure if it's actually given in the maths tables. Okay, someone can comment in the thing below if I'm getting that wrong. So it's 1 over square of n, and I just memorize it off. Like, this is often used for things like, polls or surveys, whatever. And it's a way of, if you have a survey of less than 1,000 people, the margin of error gets bigger and bigger and bigger. Or, the smaller the sample size, the larger the error. Now we can calculate, we know the sample size is 1,000. So it's 1 over the square of 1,000, okay, which calculates to be 0.0316. Okay. Now you can use the calculator for that, but whatever, let's just matter of program the calculator. Now I want to turn that to a percentage. So the way to turn something to a percentage is to multiply by 100. Okay, and I get 3.16%, which is 2 decimal places, but they only want 1. So this number here informs what I do. It's greater than 5, so my decimal place goes up by 1, and my final answer is 3.2%. Job done. Now the next part here is looking, and this question has been asked every year for the last 4 or 5 years, and it's one I've gotten better at because it's very standard. But I can imagine for a lot of students it puts the fear of God in. So if this next part is messing with you, you know what? That's fair enough. Okay. If you try go for the attempt, you know what? There could be worse things. You see here there's like 5, 5, and 5. So the attempt is worth 3. If you can get that, happy days. Now, so of those asked, 762 said they believe it is safe to give their credit card details when shopping online. Now, if you think there, before I even go any further, that's 762 of the 1,000. Now you could work that out as a percentage. Okay, that would be the same thing as 76.2%. Just multiply by 100. If you did that, you have the low partial. Okay, but let's read on. Use your answer to part A. Okay, so use your margin of error. So the second they say use the answer, you know what? Let's put the answer down. Now, if you only put the answer down, depending on the marking scheme, that just writing down the answer might get you the low partial. Okay, if you can tie these two things together, you're going to get probably the high partial. Okay, so it says use your answer to part A1 above to create a 95% confidence interval for the percentage of people who believe it is safe to give their credit card details when shopping online. Whew, so many words. So they have this thing and they call it like P hat, okay, plus the margin of error, or P hat, okay, take away the margin of error. Now this is P hat, okay. So I suppose your percentage, or your probably a better way of phrasing it, but whatever you're given, so the amount divided by the entire amount of people. Now I went percentage, okay, because we have a percentage margin of error. So your answer then is 76.2 plus 3.2, or 76.2 take away 3.2. That gives me a range of, now you could go the other way, but I put down 79.4, and put it in square brackets, and then set as far as 73. So that's the possible range of people, based on the margin of error, who feel that way, is one way of phrasing that. Now, the last part probably don't have a huge amount of space left here, okay, for this, but this is the one that when you're doing hypothesis testing, even saying hypothesis testing is hard to say. But 5 marks. Let's see if we can get the low partial. An online media company claims that 80% of people believe it is safe to give their credit card details when shopping online. Okay, so that's the hypothesis. Okay, so our HO is what they call it, says that our probability or whatever number of people equals 80%. Now, the alternative hypothesis, sometimes called H1 or HA sometimes, is that the number of people does not equal 80%. Okay, so that's going to get you to low partial if you can remember to do that in hypothesis testing. Now, there are different levels of significance in statistics. Okay, at the 5% level of significance, we're looking at, I suppose, taking information from the previous answer and going, is 80% between this range? Now, it's not. Okay, so I probably should write down that range again, but if you can see, I'm dragging down. 80% is not between those two figures. Okay, so therefore, 80% you can say is not an element of or part of, okay, 79.4 as far as 73. Okay, therefore, we reject the null hypothesis. Okay, and you can put a statement in if you want, and it says give a reason. Call a spade a spade. We reject the null hypothesis because 80% is not between 79.4 and 73. You can say that. That's what it is. So that's what you say. How you say that in the space provided there is a different thing. But that's the answer. Now, if you're achieving attempts from both of these, you know what? It can be an awkward question. But if you're going for the A or going for a high marks, you kind of need to have prepped this. Okay? And it is a tricky area. Now, part B, that's the answer to part A, sorry. Okay, then part B, we have this standard distribution. Okay, now we're always trying in statistics to look at our data and go, does it follow the standard distribution, okay, or not? Okay, and the type of statistics you'll apply will depend on the scenario. Now, if this is following the standard distribution, okay, this here might be +1 standard deviation. This might be -1 standard deviation. And that's all standard deviation is. It's a measure of how far away from the middle your data is. If you had a data that had literally like that, now we can't do it justice, that would have a very small standard deviation. Okay. If you had a line, literally a line, there was no difference. That has a standard deviation of 0. The wider it is, the larger the standard deviation. That's how standard deviation works. It's just a measure. That's all it is, a measure of the spread of our data. Now, an aptitude test was taken by 6,500 candidates. So everybody, all the 6,500 people are under this curve. The test scores were normally distributed, so it is a standard distribution. They're telling us that. That's what that means, standard distribution. Okay. For you, it won't really matter. They won't give you anything that's not standardly distributed. This is statistics 101, not advanced. Thank God. Now the mean score was 480. Okay, so we're told that's the middle score. So half the population have a greater score, half have a lesser score. And they're telling us the standard deviation was 90. Now, taking into account what I said, okay, that's going to be +90. This is going to be -90. Now, let's read it out. Okay, on the distribution shown below, the shaded area represents all the candidates who were within 1 standard deviation of the mean. Write down the value of A and the value of B in the boxes below. So it's simple. 480 to take away 90 is what? 390? Okay. I'm doing it in my head, which is a dangerous place to be. 480 plus 90 should be 570. Okay, now I should show those calculations. So if I did make a mistake, 480 take away 90. If I made a mistake there and put down the wrong answer and put that here, like the calculation is right. So you should not get penalized overly. It is worth pointing out there's only a 5-mark question and it's a 5B scale. So by doing that calculation, even getting it wrong, look, I'm definitely on the 2. Okay. So if you went 480 plus 90, or 480 minus 90. Because what else you got to do? You're given 480, you're given 90. Why not take them away? Or multiply them, or add them, or subtract them? But hoping the hell that's going to work. If it did, you got the 2 marks. Happy days. Now, part 2 then says use the empirical rule, okay, to estimate the number of candidates in the shaded region. Okay. Now, actually, let me go to the next page because I have a nice diagram put in. The empirical rule states that if you have this is your center, okay, this is your mean. If it's following the standard distribution, that means that 34% of the data is 1 standard deviation away. 24% is 1 standard deviation below. They can go further. Okay, that's like 2 standard deviations, and then 3 standard deviations, which is practically everybody, like 97.5% of the population. If you add up all the things, okay, or sorry, 99.7% of the population. Again, practically everybody. But we're only worried about this. So if they're within 1 standard deviation, okay, 1 standard deviation of the mean, they're within 68% of that. Okay, so if it's 6,500, okay, how many of the data, how many people are represented in 1 standard deviation? Well, it's 68% of 6,500. So that's I got an answer 4,420 people, which again is the majority, but 60% is the majority of the people, and that's all the empirical rule is saying. Now you have to know your statistics to kind of know what it's saying, but like Sinead said. So that's question 3 of paper 2, Leaving Cert 2020, the ordinary level maths. Okay, so if you want a copy of the notes I'm working off, just send me an email at shanetroy@gmail.com. And if you subscribe, you'll get access to the playlists for the different years and paper 1 and stuff. Right, thanks very much.